Hi, Math 117. This is Miss Griffith reporting from my garage, going over the last section of Chapter 6. There is someone playing the trumpet in the background, so enjoy. Today we are going to learn how to find a point estimate for a proportion. You've actually done this before, but to find p hat, that's what we call it, you just simply take the number of successes and divide it by n. P hat will always be in the form of a decimal. You're going to learn how to construct a confidence interval for a population proportion. We will use the formula for one example and then your calculator commands for the other example. And then we're going to determine the minimum sample size required when estimating a population proportion. We did this in 6.1 as well, but you will simply plug in values into the margin of error formula and solve for n. All right, let's get started. Okay, to find a point estimate for p, we call it p hat, all right? We just simply do the number of successes divided by the sample size. So let's do an example. In an SRS of 200 students, 78 say they are left-handed. Well, to find p hat, we just take the number of successes, in this case it is 78, and divide by n is 200, and we get 0.39, okay? This is your point estimate, all right? Okay, so next it's just talking about a sampling distribution of p hat. Remember, anytime we're talking about a sampling distribution, we have to change the standard deviation. So the mean is going to stay the same. The mean of p hat is just going to be p, the population proportion. But the standard deviation is something that we have to change. We have to take the square root of p times 1 minus p. Remember, p is always going to be a decimal, divided by n. Another way that you've seen 1 minus p written is q. So p would be the probability of success, and q would be the probability of failure, and they have to add up to 1. So this is going to be the standard deviation part of our formula. Okay, well, here is our generic formula that we've been using for all of Chapter 6. You do the statistic or a point estimate plus or minus the critical value times the standard deviation. The critical value times the standard deviation, that is always going to be the margin of error. Well, our statistic or our point estimate in this section is going to be p hat. We just learned how to calculate that. Our critical value, we are going to go back to our z-score chart here. So when we are trying to estimate a population proportion, we are going to use the standard normal curve. And then our standard deviation we just learned is the square root of p times q divided by n. All right. In here, that is all written here. Again, just remember 1 minus p hat. Another way to write that is q. Either way is great. All right, as a reminder, these are our most common confidence levels for our z-score chart, and here are the corresponding z critical values. And just to remind you how these can be found in case they are asking you maybe for an 85% confidence level. Well, you always draw the standard normal curve. So let's find the z critical value for 90% confidence level. Well, we would put the 90% in the middle and see how much area would be in each tail. Well, that would be, we're missing 0.1 of the area, and we know it's symmetrical, so we divide 0.1 divided by 2. We know the area in this tail is 0.05. The area in this tail is 0.05. Anytime you're going from an area to a z-score or an area to a t-score, you use inverse. Well, we want to use inverse norm because we are now back to the Z chart. The area is going to be 0.05, mu is going to be 0, and sigma is going to be 1. When you put this in your calculator, you will get a negative 1.645. Well, this z-score would just be the positive version of that. We always use the positive for our z critical value. So 90% would be 1.645. Here's an example that we're going to go through. In number 1, we're going to use the formula, and then in number 2, we will use the calculator. Either way is great. This says in a survey of 420 U.S. females aged 18 to 64, 279 say they have gone to the dentist in the past year. Okay, well, we first want to know what p hat is. All right, well, p hat, again, is the number of successes. That's going to be 279 divided by n. N is 420. P hat then is going to be 0.664. So let's find the 90% confidence interval here using the formula in number 1. All right, we just calculated our point estimate, 0.664, plus or minus our z critical value. Z critical value for 90% is 1.645. And then we multiply this by the standard deviation. P is 0.664. Q is 1 minus 0.664. So that's 0.336, all divided by n. N is 420. All right, this part is our margin of error. So I'm going to put this in my calculator now. So 0.664. When I put this part in my calculator, I get that the margin of error is 0.0379. Okay, so this is going to help us create our confidence interval. We need to calculate the lower bound and the upper bound. To get the lower bound, you do 0.664 and you subtract the margin of error. To get the upper bound, you would take the point estimate and add the margin of error. All right, so when we do this, we get our lower bound is 0.6261, and our upper bound is 0.7019. So that is your confidence interval, and you always need to know how to interpret that in a sentence. To interpret that in a sentence, I'm just going to switch to the next slide for just a minute. We would say, and this is rounded a bit, but we would say with 90% confidence, you can say that the population, and now we've changed it, proportion. Remember in 6.1 and 6.2, we were doing means. So we can say that the population proportion of U.S. females aged 18 to 64 who say they have gone to the dentist is between 62.6% and 70.2%. It would also be okay here for you to say is between 0.626 and 0.702. So that's how you would interpret the interval, the confidence interval we just found with the formula.